So now we are moving to the next question, that is question number 80. So question number 80 is on your screen. Which one of the following is an example of a thermosetting polymer? So this question is come from your polymer chemistry of your class 12 NCERT. So now we are moving to the solution part. So they asked about the example of thermosetting polymer. Among them, if you see the option number 4, this is nothing but this is the backlight, and backlight is nothing but this is a thermosetting polymer. Okay. So option number 4 is the correct answer of your question number 80. So now we are moving to the next question, that is question number 81. So question number 81 is on your screen. Which of the following organic compounds polymerizes to form the polyester dacron? So this question again come from your polymer chemistry of your class 12 NCERT. So now we are moving to the solution part. So if you see here, they asked about the polymerization to form polyester dacron, and this will form by your ethylene glycol plus your terephthalic acid. So now see option number 1 is propylene and para, no, this is not the option. Benzoic acid, no, this is not. If you see terephthalic acid and ethylene glycol, okay, terephthalic acid and ethylene glycol is the correct answer, that is option number 3 is the correct answer of your question number 81. So now we are moving to the next question, that is question number 82. So question number 82 is on your screen. Which one of the following is not a common component of a photochemical smog? So this is come from your environmental chemistry of your class 11 NCERT. So now we are moving to the solution part, and the solution is very easy for this question, that is they are ask you which is not a common component of a photochemical smog. Now if you see the option number 4, that is chlorofluorocarbon, is not a component of your photochemical smog. So option number 4 is the correct answer of your question number 82. So if you see the polymer, environmental chemistry and the biomolecules, from those chapters they directly give you the NCERT statements. Okay, so they are not give you any calculations part. So always don't forget to study the theoretical part of your environmental chemistry as well as biomolecules and your polymer. So now we are moving to the next question, that is question number 83. So question number 83 is on your screen. In the Gelder's method for estimation of nitrogen present in a soil sample, ammonia evolved from 0.75 gram of sample neutralized 10 ml of 1 molar sulfuric acid. The percentage of nitrogen in the soil is. So this question is come from your quantitative analysis of your some basic organic concept which is given in your class 11 NCERT. Okay. So now we are moving to the solution part. So in quantitative analysis they mentioned the Gelder's method, and Gelder's method basically used for ammonia or for nitrogen types compound, not ammonia, that is basically used for the nitrogen compounds. Okay. So now if you see there is a direct formula is given, that is your 1.4 into N1 V divided by your W. Okay. So this is the direct formula to find out the nitrogen. Okay. So how much it is? 1.4. What is the normality? How much normality? Here molarity they are given, and this molarity is nothing but your normality. Okay. 1 molar H2SO4. If I ask you to find out the normality, so what you do? You just do the n factor into your molarity. Okay, this is the formula. So what is the n factor here? Here n factor is 2, and what is the molar is given 1. So here normality will be end up with n. So, normality is 2, what is the volume V is given here 10 ml. So, it is 10 ml divided by what is W? W here it is given as your gram, that is 0.75 gram. Now, if you solve this part 4.2 into 2 into 0.75 gram, it will be end up with like that. If I am taking as 4, here I am taking as 2 and 10 and 0.5 0.75 I am directly taken as 0.80. Okay. So, now it will be as coming as 0.40, that is 0.4 0.10, and if it will be go, it will be as 10 divided by 100, it will be go above, that is will be 100%. No, this is. So, if you are doing this one 4.2, sorry 1.4, not 4.2, 1.4 and 0.75. So, it will be as 14 into 2 divided by 75 into 100. So, if I 5, 20, 15, 4, 3 and it will be 14 to 2, 28 into 4, 112. If I am doing 112 divided by 3, so it will be this value is approximately come as 37 or 38. Okay, 37 or point something will be there, means 38. Now, if you see option number 1, which is the closest value is your option number 1. Just try to solve this part 1.4 into 2 into 10 divided by 0.75. When you do, if you are in examination, you just take the closest value, like in 1.4 you can take 1.4 into 10. So, it should be 14 into 2. Now, 0.75, that 100 will be go above and 75 will be down. Now, after doing this whole calculation, you end up with your answer is 37.3. So, option number 1 is the correct answer of your question number 83. So, this is the direct formula based question, and formula I already written here. So, question number 84 is on your screen. What products are formed when the following compound is treated with Br2, that is bromine, in the presence of FeBr3? So, now we are moving to the solution part. Now, one more thing always remember. So, this is nothing but this is your ortho-para directing groups. Okay. That is your plus I groups is always be a ortho-para directing group. This one is also an ortho-para directing groups. Means whatever nucleophile will become, it will be attack on this ortho. Means if this is the position, this is your ortho, this is your para, and so this is ortho, this is meta position, and this is para for this CH3. Okay. Suppose I naming here as A. So, ortho for A is this one, meta for A is this one, and para is A for this one. Now, this one I am mark it as B. I am just changing the color. Okay. So, for this blue color, for this one ortho is this one, ortho is this one, meta is this one, and para is this one. Similarly, if you go for this side also, ortho is this one, meta is this one, and this is your para position. Okay. This for this methyl group. Now, let us see where is our ortho and para group we are obtaining. Now, if you see the option number 1, this is ortho for this one, this is ortho for this one. Okay. Here if you see, this is ortho for this one and para for this side. This one is also possible. Now, if you see, this is ortho for this compound. Okay. And from this side if you take, it will be para position. Okay. Now, for this one ortho for this one, ortho for this one. Okay. So, this also is possible. Now, we are moving to the another options. Now, if you see option number 3, this is ortho from this side and para from this side. For here also, if you see ortho from this carbon and para from this side. If you see this one is also from this side it will be ortho, but from this side it will be meta. So, this is not possible. So, option number 4 we can neglect it out. So, we have left it out option number 3, option number 2 and option number 1. Here this is ortho and para, okay. Means one side it will be ortho and another side it will be para. Here one side it will be ortho and another side it will be para. So, now see the option number 2 whatever they are given. So, in option number 3 we are obtaining like ortho para and ortho para. Here it will be ortho, this one side is also ortho, from this side it will be ortho and this side it will be para. Now, from this side if you see this is also a bromine group and it will be an ortho, and from this side it will be para. So, if you see this is in ortho position, but this position is crowding position. Crowding for what? For this methyl group and this methyl groups are make a crowd on this position. So, this position is not easily available for attacking. Okay. So, that is why this is not possible due to the crowding effect. Okay. So, this is not possible. So, means option number 1 also we can neglect it out. Maybe it is a ortho position, but the reason is here crowding effect will shown. Now, if you see in option number 2 also, see this position again it is not possible due to crowding. So, what we left it out? We have to left it out only one answer, that is your option number 3, and option number 3 is the correct answer of this question. So, now we are moving to the another question, that is question number 85. So, question number 85 is on your screen. Which of the following compounds will undergo racemization when solution of potassium hydroxide hydrolysis? So, this question is basically a bonus question, because whatever options they are given it will be not matched with the suitable solutions. So, let us see what is the suitable solution for this question. Now, if you see here only one option, that is your option number 4, it will give you the suitable product, remaining are not the correct answer for this. But if you see options, in options they are not giving anywhere, only 4, okay. They are giving 1 and 2, 3 and 4, 2 and 4, 1 and 4. So, this is the bonus question for your question number 85, but if you see the suitable answer is your option number 4. So, now we are moving to the next question, that is question number 86. So, question number 86 is on your screen. Among the following sets of reaction, which one produce anisole? So, now we are moving to the solution part. So, if you see the structure of anisole is nothing but OCH3. So, this is the structure of anisole. Now, how to obtain this anisole structure? So, this structure you can obtain when its phenol OH, phenol is react with in the presence of base like NaOH. So, what will happen? This is base. So, it will abstract this proton. So, what will happen? This bond will shifted here, here negative sign will be there and this positive. So, you get this kind of adduct. Okay. So, this is not our product, this is our adduct, that is O minus Na plus. Now, when this one is react with CH3I, that is our alkyl halide. So, what will happen? This O minus will be attack on this carbon, this iodine will be left out and left out as sodium iodide. So, we are obtaining as our product, that is anisole. Okay. This is our product. So, if you see where we are getting those reactant. Now, first one is not possible, aldehyde is not possible, alcohol may be possible, here also alcohol is possible, this is also possible, this is also not possible because here no alcohol. Now, if you see the second option here, NaOH means option number 2 is the correct answer, because here they are giving us neutral FeCl3, and in this process we are not using any neutral FeCl3. So, option number 3 also we can neglect it out. So, we left it out only one option, that is one answer, that is option number 2 is the correct answer of your question number 86. So, question number 87 is on your screen. Which of the following will not be soluble in sodium hydrogen carbonate? So, now we are moving to the solution part. So, if you see, they ask about which is not soluble, again mark it not, okay, not soluble they ask. Now, if you see, this is orthonitrophenol, okay. So, orthonitrophenol is an weak acid, okay. Now, when it will be react with sodium hydrogen carbonate, that is NaHCO3, which is a weak base, it will be react and it will be give this product, okay, ONA and here NO2 plus it will be give H2CO3, okay, H2CO3. Now, if you see, this is weak acid, this is weak base. So, this is our strong base. So, if you see, this is our strong base and this is our strong acid. So, this forward reaction, this is actually a reversible process, okay. This is a reversible process. So, the forward reaction is not possible here, okay, because from weak acid, weak base we are getting strong base and strong acid, it is not possible, but backward reaction is possible. So, forward reaction not favored, okay. So, this will not possible. So, if you see your option number 3, that is orthonitrophenol is the correct answer of your question number 86, which not be soluble in sodium hydrogen carbonate. So, now we are moving to the next question, that is question number 88. So, question number 88 is on your screen. Which one is the most reactive towards nucleophilic addition reaction? So, now we are moving to the solution part. So, they ask about which is most reactive, okay, most reactive towards the nucleophilic addition reaction, means that reactant whatever we are taken, it should be a good electrophile, and when it will be a good electrophile which having the lower density of electrons, because nucleophile having a higher density of electron and electrophile having a lower density of electrons. So, nucleophilic addition reaction, okay, nucleophilic addition reaction is directly proportional to the minus I group and your minus M group, okay, minus I group and your minus M group, or we can say it is a directly proportional to electron withdrawing group. When an electron withdrawing group is present on that ring or that compound, it will be more reactive towards the nucleophilic addition reaction. At the same time, it is be inversely related with plus I or plus M, or we can say it will be inversely related with electron donating group, okay. So, when electron donating group is present, that compound, that ring, it will be not a better reactive group towards the nucleophilic addition reaction. So, for this we have to find it out which having the most minus I minus F group or electron withdrawing group. Now, among this all option, if you see only one option, that is your NO2, which is a highly minus M character, or you can say it will be a most electron withdrawing group. As a result, option number 4, it will be the most reactive towards the nucleophilic addition reaction. What will happen when NO2 will be there? It will pull the electrons towards itself. As a result, the electron density will be decreased on this ring. So, if electron density will be decreased in this ring, so it will be a good electrophile, When it will be a good electrophile, it will be easily attacked by our nucleophile. So, option number 4 is the correct answer of your question number 88. So, now we are moving to the next question, that is question number 89. So, question number 89 is on your screen. Identify Z in the sequence of reactions. So, now we are moving to the solution part. Now, if you see, they given HBr, that is hydrogen bromide, in hydrogen peroxide. So, it means whatever bromine addition will take place, it will follow anti-Markovnich's of rule. So, what anti-Markovnich's of rule said, your bromine group will be attached, or your Br, that is your nucleophilic group, is attached on that side where more number of hydrogen is present. Now, if you see in the double bond, here one hydrogen is present and here two hydrogen is present. It means your bromine group will be attached with this position. So, what you get in your Y you are obtaining in this compound CH3, CH2, 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 Br. Now, when it will be attacked with this base C2H5ONa, it will be an SN2 reaction. So, what you are getting? You are getting your product as CH3, CH2, CH2, CH2O, CH2, CH3, means this part, that is O minus C2H5, it will attach with this and it will be left as NaBr. Okay. So, NaBr will be left out, because what will happen here, Br minus will be left out, Br minus. So, it should be an positive. Now, here C2H5O minus Na, so this minus will be attacked on this position and you are end up with this product. Now, see where you are end up with this product. Now, CH3, here CH2, 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 3 will be there, OCH2. So, this is the correct answer. Now, if you see the remaining part, here also CH3, CH3, here means it will be the structure look like this, CH3 and CH3, but in answers we are not get this one. So, option number 2 we can neglect it out. Now, if you see in the that ether part, it should be a C2H5, that is CH2, CH3, but here CH3 will be there. So, this is not our option. Now, in this case also it will be not the correct answer. So, if you see only option number 1 is the correct answer of your question number 89. So, now we are moving to the last question, that is question number 90. So, question number 90 is on your screen. Which of the following organic compounds has same hybridization as its combustion product is CO2? So, now we are moving to the solution part. Now, if you see the CO2, the structure is look like this, okay, it is a linear type. So, what is the hybridization? The hybridization is sp hybridization. Now, if you see among all, ethane does not have sp hybridization, ethene also sp2 hybridization, ethanol also does not have this sp hybridization, only your ethyne molecule, that is HC triple bond CH, each having this sp hybridization. So, your option number 2 is the correct answer of your question number 90. So, my dear students, today we are solving more previous year question papers based on our chemistry tricks and with knowledge. So, next class we are trying to more solving the question papers based on our chemistry knowledge. So, till then keep learning, keep revising and keep studying.